Today's experiment is about Experiment 4, Designing and Making of Concrete Beam Sample, performed by Group 4 of CE14E2, which consists of Galarrita, Guiling, Gulay, and Honculada.
We based our laboratory procedure in accordance with ASTM C31. Concrete beams are structural elements that designed to carry transverse external loads. The ultimate goal of the sampling process is to have a sample that is an average representation of what is going into the pour to get the most accurate strength value in the lab. Also, to design and make a beam that can withstand the greatest applied load. The materials and lab equipment to be used are beam molder, tamping rod that is longer than the depth of the mold by at least 4 inches but not more than 24 inches of the overall length, rubber mallet, shovels, trowels, cement, fine aggregate, and coarse aggregate.
We first measured the beam mold in which its length and depth is 0.155 meters and its width is 0.537 meters. Using the class ratio of 1:1.5:2.5, we calculated for the required amount of cement, fine aggregate, coarse aggregate, and water. The cement is 24.39 kilograms, the fine aggregate is 36.585 kilograms, and the coarse aggregate is 60.975 kilograms. We mixed first the cement, coarse aggregate, and fine aggregate. We slowly added about 12 liters of water into the concrete mixture until it was homogeneous. After mixing, the other group took out a sample from the concrete mix and poured it into the cone mold to perform the slump test. Our concrete mixture passed the slump test. We greased each side of the 3 beam molds. We poured the first layer of concrete mix, which filled half the beam mold. We used the tamping rod to consolidate it for 60 times, making sure that it will not forcibly strike the bottom of the mold. We then tapped the sides of the beam mold for about 15 to 25 times using the mallet. We poured the second layer of concrete mix, then consolidated it again by using the rod and the mallet. We smoothened it using the trowel to create a clean finish so we can write our group number and section. We repeated these steps for 3 times, but on the third beam mold, it did not fill the beam mold. We were only able to make 2 beam mold samples. We set it aside where we can store it in a safe place for the curing.
After calculating the concrete mix component, we ended with 0.0286 cubic meters of cement, 0.0429 cubic meters of fine aggregate, and 0.0716 cubic meters of coarse aggregate. With this, we mixed all these components, and the result of it was dry mixture, in a sense that the coarse aggregate can still be seen. Another reason could be that our water mixture was not high enough, because at the last part where we put the mixtures on the beam, we had to add water on the remaining concrete mixtures. The slump test was the first thing that we did, and it was a success right from the first trial. In making the beams, we were able to make 3 beam samples, but the third one was short of the second layer, so meaning only the first layer and a little bit of the second layer was filled with the concrete mixture. We even have to take some mixtures from the third beam so that the second beam could be completed.
After performing the assigned laboratory exercises, the group was able to find out that the cement, gravel, and sand mixture was not enough for the 3 groups assigned. Thus, we only had 2 beams completely filled and 1 7/8 filled. We concluded that such failure was attributed to our mishandling of the mixture, such as spillage and hardening of the mix on the mixing tray. Our group is inexperienced with mixing aggregates and cement, thus there were many mistakes along the way. As of writing this paper, the group has not yet been able to perform the testing of the mixture's compressive strength. However, our mixture was able to achieve the passing inch requirement of the slump test, proving that the class mixture of 1 cement is to 1.5 of fine aggregate and 2.5 of coarse aggregate is acceptable.